Hello Tech World, this is TechThoughts. This is an operationally designed series that aims to get you ramped up and using PowerShell quickly. This is video 6 in this series, Taking Control with PowerShell Logic. The corresponding article for this topic can be found on the TechThoughts.info blog, which I've linked in the description below. If programming logic is a relatively new concept for you, I'd like to encourage you not to shy away from this component of PowerShell. I'm going to show you how easy it is to implement some of these logic concepts with a few practical examples. If you're in a more operational role, adding PowerShell logic can really take your PowerShell capabilities to the next level. The IntelliSense capabilities of VS Code make adding some of these logic concepts extremely easy. If you haven't gotten set up to do PowerShell inside of Visual Studio Code, make sure to check out my video on getting set up for PowerShell development. So the first logic component we're going to discuss is going to be conditional statements. In PowerShell, that's going to be your if statement. So notice as I type in if that I automatically get some choices on the IntelliSense, and if I click tab, it went ahead and scaffolded that if statement for me. And look how easy this is to go ahead and get started with, because now we have the if, open parentheses, our condition goes inside of those parentheses. We have an open, close, and bracket. I can do an elseif, and notice again that I can tab, and I can do an else, and again, tab. So I'm not having to write a lot of code here. The VS Code kind of does some of the heavy lifting for me. So let's dive into what's going on here. So we can specify a condition within this first evaluation of if, and then we can perform an action depending on what criteria that we specify in this if statement. We could specify a different set of criteria in our else if and perform a different action based on different criteria here. If it doesn't meet our first criteria and it doesn't meet our else if second criteria, we can fall back to an else where we'll perform actions if none of the criteria is met. This is basically as complicated as conditional statements in PowerShell are. So you simply need to identify what conditions you're looking for. And this is the basic scaffolding that you'll use moving forward for all conditional statements inside PowerShell. Let's dive into a practical example. So I pasted some code here and let's walk through it. The first, and I'm using F8, is going to be to run this line, which is loading the path variable with ctest, which is a local directory on my file system. You can adjust for whatever file or folder is on your operating system. For Linux users, you could always use /home, for example. Then I'll go ahead and use the commandlet test path, which will evaluate that path that I just specified, and we'll load the results of that commandlet inside eval path. So I'll go ahead and run that now. And if I pound out eval path down here in the console, you'll notice that it returns true, because test path only returns a Boolean value, true or false, depending on if the directory exists or not. So here we are, no surprises with our conditional if statement. And in our if, which we now know contains a bracket for the condition, we are saying if the eval path is equal to true, then go ahead and perform this action, which is write hosting out to the console path verified. Otherwise, we are going to evaluate if eval path is false and write out the path is not verified. So this is a quick check to see if that directory exists. I'll go ahead and load all of this into memory. And notice that on the console, ctest is verified. If I change this to a directory that does not exist, so I could put in here, nope, doesn't exist. And if I run this, you'll notice that because it does not exist, we come down here to the else if and see, nope, doesn't exist, not verified, is what we see out on the console. And that's basically it for conditional statements inside PowerShell. You simply specify the criteria that you're trying to evaluate and perform whatever action based on when that criteria is met. Don't forget that this does use comparison operators, things like equal, not equal, greater than, less than, and there's a full list of those on the TechThoughts.info blog if you'd like to learn more about what comparison operators are available so that you can make really intelligent and powerful conditional statements. Next up is going to be our switch in PowerShell. And switching is a lot like an if statement, except that it can evaluate multiple conditions. So I'll go ahead and paste a quick line in here, and I'll say the a value variable, which is going to be strongly typed as an integer, so we know this is going to be a number, is going to read host and ask the user enter a number. So I can go ahead and F8 that. Notice that I get prompted down here for entering a number, and I'll go ahead and type in 5, and now you can see that a value is equal to the integer number 5. So we can do a quick switch example here. And again, I'm not going to type all this out. I'm just going to type in switch. I get my IntelliSense, click tab. And again, that goes ahead and scaffolds the switch for me. You don't have to memorize the structure of these things if you're not familiar with PowerShell logic syntax. So what this is asking in the switch is, what variable do I want to evaluate for multiple conditions? And the variable that I want to evaluate is going to be a value. So I'm going to replace x with a value. I'm going to go ahead and add in some conditions now. You can add as many conditions as you like. So I can do things like this. I can add in a 1. And so let me walk you through this. This is saying that the switch is evaluating a value, and if it's 1, it's going to perform this action. I'm going to paste in a couple more here so that you can kind of see where this is headed. I'll bring this console down so we can see that a little bit better. And so here we're going to evaluate a value, and if it's 1, we're going to do this action. If that value is 2, we're going to do this action, so on and so forth. And then we can provide a default value if none of those conditions are met, where we perform that action when none of the criteria is matched. So here is our practical example of a switch where we're evaluating the integer. Depending on which integer is found, it will go ahead and write out and tell us the number that it actually was entered. And if it doesn't match any of these, it'll default to saying, sorry, I don't know what to do with that number. So we'll go ahead and load this into memory. I'll get prompted, of course, to enter a number. I'll type in 4. And notice that we get you entered the number 4 down here on the console. Because when this switch evaluated a value, it matched the condition 4 and performed the action that was inside of these 2 brackets. If I enter a number that is not part of that, it will default back to the default parameter in the switch. So if I type in 10, sorry, I don't know what to do with 10, because we have not provided it the logic to handle that particular use case. If you're following along at home, try adding a couple more switch statements to handle the numbers 1 up until 10. With switch statements, keep in mind that, again, it's kind of like an if statement, and we could accomplish the exact same thing here with multiple if statements. However, switches are a little bit cleaner to look at and easier to code. So if you're evaluating for multiple conditions, a switch might be more appropriate than an if statement. That concludes conditional statements for PowerShell. And now we're going to switch over to loops. Loops are a basic programming structure of any computer language. And again, don't shy away from some of these more advanced concepts. I'm going to show you how simple it is to work with some of these. Okay, so our first loop type is going to be a for loop. I'll go ahead and paste in an example, and I'll walk you through what's going on here. Typically in a for loop, you'll declare I, which is kind of like a placeholder variable that you're going to be using to run the loop itself. Our second condition, which is articulated here, is that we're going to run the loop until I is less than or equal to the number 15. And then our third condition, we're going to increment I on every iteration of the loop. So this loop will start at 0, and every time that it runs through the loop, it will increment I by 1, and the loop will continue until it hits 15. Notice then in my actual action in the loop that I'm writing out to the console using write host with the foreground color set to I. So we'll go ahead and load this into memory and see what this accomplishes. And I like to refer to this as the rainbow for loop example. So notice that on each iteration of the loop, I, of course, was incremented by 1, which is done with this I++. So on the first pass of the loop, we got the number 1. On the second pass, the number 2, so on and so forth, all the way until we hit number 15. Notice, because write host was referring to the variable I, that it wrote I in each iteration of the loop, incrementing by 1, which is why we see the numbers 1 through 15 here. And you can control the foreground color of the write host by specifying a color number, and that's why we get the rainbow effect here. It's because we're changing the foreground color to a different number on each pass of the loop. So this is a simple example of how to accomplish a for loop. You could, of course, change all of these. You could start at 5. You could go up to 500. You could perform various actions inside of here. So a for loop is a really great way to perform a lot of different actions or a set number of actions very quickly. For loops are used quite a bit, so I'm going to give you a secondary example here. And let's walk through this one. A string is being loaded with Jean-Luc Picard. So if we pound out a string down here, you'll notice that it is loaded with that particular string. I'm going to go ahead and declare a second variable and load it with nothing. So notice that if we pound out reverse string down here, it's currently a blank string. And now I'm going to pop those into a for loop, and this one is going to be in reverse. So instead of incrementing I each time, I'm actually going to be subtracting I each time. And instead of starting I at 0, I'm going to start I at the A string length. Let's take a look at what that is. So if I do A string, which we know is loaded with Jean-Luc Picard, and do length, the actual character count of that is 15 total characters inside of that string. So we're starting here at 15 is what this first condition is. And then we're going to go on this loop until we hit 0. And again, we're going to be subtracting I each step of the way. Now notice what I'm accomplishing inside of here. In the reverse string, I'm plus equaling whatever the A string is. And remember, we're counting backwards. So on the first iteration of this loop, this A string I, because we're starting at the end, is going to be the last character inside of the A string variable. So again, we're starting at 15, going down to 0, subtracting by 1 each time. And on that first pass, this is going to be, because we're starting at the end, the last character in here. You probably have recognized what this is going to accomplish. We're going to reverse the string by loading each character one at a time in reverse order back into this variable. So I'll go ahead and load all this into memory and run it with F8. And notice that we do get a reversed Jean-Luc Picard with DRAC-IP naj. So again, for loops are very powerful. They can go both up and down, and they allow you to do some really complex stuff very easily. Our next type of loop is going to be a for each loop. I'm going to go ahead and paste an example and highlight some of the differences. The for loop loops a number of times that you specify, but a for each loop is going to actually loop through each item in a collection. And a collection could have a number of items that you might not actually know about beforehand. Let's walk through this example so you can see why it's sometimes more appropriate to use a for each loop. So again, we're loading up path with a local directory. Don't forget to change to a directory that exists on your computer if you're following along. We're going to go ahead and declare a strongly typed total size of integer type and set it to 0. And then we're going to go ahead and get all the file information using getChildItem recursively. So every single file or folder that's inside that path, and load it into file info. Now, a for loop is not appropriate here because we don't know necessarily how many files and folders are going to be returned by getChildItem. So we're going to use a for each and loop through every single one of those items, even though we don't know necessarily how many there are. So this variable that's declared on the initial portion of the for each can be named whatever you want. It is not important what this is. It is simply the current object in the loop. So I could have named this file poke, for example, or any different number of variable names. But when you do that, you do have to change it in the actual logic portion as well. So if I change this to file poke, I have to change this to file poke as well. Remember, whatever you declare here is the current object that's being evaluated in the current iteration of the loop. So I'm going to go ahead and change that back to file in both locations now that we understand what that's doing. And again, for each file in file info, I'm going to go ahead and determine the length of that file that I'm looking at, and then plus equal that to total size so that I will get the total size of everything that's inside of this path. Notice that we're doing a right host at the end with some variables. Don't forget your double quotes because we are using variables inside of here. And I'll go ahead and run this in memory. It went ahead and got all of the file information and noticed that the total size of files in ctest is 580 megabytes. This was made possible by that for each loop looping through every single file piece of information that was collected by getChildItem. And again, we use this as a placeholder to designate the current object that we're working with inside of the for each loop. Next up is going to be while loops. There are two types of while loops. There are do while loops and there are while loops. And I'll be walking you through the differences and why you would use one over the other. In our previous examples, for loops looped through a specified number of times that you specified. For each loops loop through the number of items in a collection that you may or may not know ahead of time. But while loops will generally loop until a condition is met of some kind. So on a do while loop, the difference here is that a do while will always perform the initial portion of the loop at least once. So let's look at this example. Path verified is set to Boolean false. And inside of this action of the do, we're going to prompt the user to enter a file path. We're going to combine our conditional statement using an if statement. And if the test path is true, then we're going to go ahead and set path verified to true. We will only set path verified to true if test path is true. This is implied here because test path will return a Boolean. You could also write this with additional brackets and equal to true, but that's a little bit more verbose, and you don't necessarily need to specify that when working with a commandlet that returns a Boolean value. So we can leave that just as if test path path. So again, if that condition is met, we'll set path verified to true, and this will continue to loop until path verified is not equal to false. So while path verified is equal to false, continue the loop, and this will endlessly continue the loop until path verified is equal to something besides false. So let's see this in action. I'm going to go ahead and load it in. Unsurprisingly, I get please enter a file path to evaluate. We're seeing that right here. So because it's a do while, we're always going to run the first iteration of the loop at least once, and we're seeing that right here. I'm going to go ahead and enter C test, which we know does exist on my test device. Go ahead and bring this up a little bit. Click enter, and the loop is done. We don't get any more iterations of the loop because it tested the path that I provided. It set path verified to true, and so there was no reason to repeat the loop. And we broke out of the loop because the condition was met. Let's go ahead and load this again. And this time, we'll provide it. Nope. Doesn't exist. And we go ahead and repeat the loop because path verified was not set to true. This is going to continue endlessly until that condition is met. So make sure that you're accounting for that inside of your do whiles and while loops, because these will repeat endlessly until the condition is met. Now let's contrast that with a normal while loop. In a normal while loop, it is possible that you might never actually enter the loop at all. So notice here that I've hard set path verified to true. And this will only enter the while loop if path verified is equal to false. So if I run this, nothing occurs. We never enter the while loop. We never prompt the user to enter a path, and we never evaluate it because this condition was not met. If I set this to false, then while path verified equals false is condition met, and we will get prompted for please enter a file path to evaluate, and we'll operate like we saw before. So that's the primary difference between a do while and a while. A do is going to do it at least one time, while a while loop performs a very similar functionality, but may or may not run depending on if this initial condition is met. Again, please don't feel like you have to memorize these. You can simply type in while, click tab. It scaffolds these things for you, making it very easy. Now let's explore some of the native commandlets that are available in PowerShell that also perform some conditional logic. And the first one we're going to talk about is WhereObject, which is a commandlet that you can use within the pipeline. So WhereObject is very much like a combination of an if statement and a loop, because it's going to be kind of if condition is met in exploring each object in the pipeline and determining if a condition is met, just like an if statement. But it's also like a for each loop in that it will loop through every single item in the pipeline. Let's walk through this example I have right here to see what's going on. So we're starting a large processes variable and we're loading that up with get process, which of course is going to get our processes running on the machine. Now notice that we're piping that to WhereObject. And the criteria of WhereObject is if the working set, which is the memory that's used by the process, is greater than 50 megabytes. So this is only going to get processes that are using a lot of memory. So again, WhereObject is kind of like an if statement in that it is evaluating some criteria, and it's also like a for loop because it's going to loop through every single get process that's returned from the get process commandlet. So if we run this right now, then our large processes variable will only be loaded with those variables that have memory being consumed that's greater than 50 megabytes. It is possible to perform this exact same logic using normal logic statements. So I could declare an array of large processes. I could get processes, load that into the processes variable, and then I could use a for each loop for each process and processes if that process memory type is greater than 50 megabytes, then go ahead and add that into the large processes array. These are both accomplishing the exact same thing. And notice that my large processes is putting out the exact same Firefox data, so on and so forth. So WhereObject is a great way to filter whatever a commandlet returns without having to break out of the pipeline. It's a lot cleaner, a lot simpler, but you can still achieve it if you want to be more verbose and use normal conditional statements. The other native PowerShell commandlet is going to be ForEach-Object. And based on that name, we're going to find that, not surprisingly, that has a lot to do with a for each loop. And again, because it's a native commandlet, it can be used within the pipeline without having to break out and do actual conditional logic statements. So in our for each object example, again, declaring path and test, ctest, we're going to start off with our folder count at 0. We're going to go ahead and get every single thing that's inside of ctest using getChildItem. And then we're going to pipe it to for each object. Now the syntax here is to provide it the process that you would like it to go ahead and evaluate. So in here I have an if statement. And what we're evaluating here is if the current object in the pipeline is a PS container, which means it's a directory or a folder, then go ahead and increment the folder count. So having all of this on one line can look a little confusing, and you'll notice that if I highlight all this, right click and click Format Selection in VS Code, that it can break it out for you if you find it a little bit easier to read on secondary lines. So again, for each object in the pipeline, we're processing, hey, is that object a folder or a directory? And if it is, the condition is go ahead and plus folder count by 1. So let's see this for each object in action. We'll go ahead and F8, and we can see that there are no folders, subfolders inside ctest. Just like WhereObject, you could accomplish this with more verbose conditional statements. But again, the for each object allows you to stay within the pipeline. It's a little bit cleaner and a little bit simpler to read. And that's basically it. A couple of conditional statements, if, elseif, else, a switch, and a couple of different loop types. We had our for loop, we had our for each loop, we had our do while and while loops. And now you have practical examples to reference. If you want to see those, don't forget to check out the TechThoughts.info blog. Let's wrap up this video with a closing example. I'll go ahead and click Control N, open up a new tab here in VS Code, and paste in our final example. This may look like there's a lot going on, but I'm going to break it down and show you exactly what's happening. We're starting off with 3 variables just so we can do some counting. We're going to count some files, we're going to count some folders, and we're going to get the total size of everything that's inside of a directory. So we're declaring those variables and setting them all to 0. Nothing special there. Our second variable, we've seen this a couple times, path, put in whatever directory that you would like here. Now we have a variable for storing the raw file info that's going to get returned from getChildItem on that path that we previously specified, and we're going to recursively look in every subdirectory. So none of this is very complicated, and we've done this in previous videos. But now let's take all that raw information and start doing some conditional evaluations and using a for each loop to get some insight into what's going on with this directory. So we're going to loop through using for each every item that's inside of raw file info, which is returned from our getChildItem commandlet. So once we enter inside of this for each loop, we're going to start doing some conditional if statements. If the current object item is a PS container, which means it's a folder or a directory, folder count increment by 1, which means we're going to add 1 to our folder count. If it's not a PS container, we're going to do an else statement. And that means, hey, if it's not a folder or a directory, that means it's a file. So we don't need to do an else if here. An else is sufficient because if it's not a directory, then it's going to be a file. So else, this is a file. We'll go ahead and file count plus increment by 1. And then we'll also add the current file's length, giving us our total size of the directory. So essentially, at a high level, what's happening here is we're going to loop through every item. If it's a directory, we're going to count it. If it's a file, we're going to count it. And we're going to get the size of every file that's inside of that path that we specify, giving us a total size count. And the last thing is generate some output so that the user can see what's going on. We're going to give a breakdown of path. We're going to give the total directories, the total files, and the total size of our files in this write host out to console. So let's get all this loaded into memory. Click F8, and notice down here that there are no directories inside of ctest. The total file count is 4, and the total size of those files was 580 megabytes. So using some simple if-else, a for each, we can generate some really rapid and insightful information about what's going on inside of our file system, and the sky is the limit from here. If you're following along at home, try removing the recurse statement and seeing what effect that has on your output results. Remember that all of this information is available in written format on the TechThoughts.info blog. If this video helped you out, go ahead and click that like button and subscribe for more TechThoughts videos.